Hello, welcome to our final project presentation for the network security course. I am Nietkali Nurmanov and
I'm Aidos Izbasarov. Today we will present our comparative security for a comparative solution for a security enterprise network.
And our project focus on defense in depth architecture. We didn't just configure connectivity, we implemented wired security using Cisco 2911 routers, zone-based firewalls, and IPC technology. It's fully complying with the project requirements for modules 1 through 12. And let me start with the network design. I took the role of the network security engineer. First, regarding the hardware, we utilize the Cisco 2911 integrated services router to enable advanced security features. Next, I divided into 3 zones, logical security zones. The first zone is inside zone for our trusted WAN employees. The next is DMZ zones, strict isolation for public service, and outside zone. It's connected to the ICP router, representing the untrusted environment. Before configuring traffic policies, I have configured a basic setup for all devices, setting their descriptions and IP addresses on the interface. Following Module 4 recommendation, I completely disabled Telnet due to its lack of encryptions. Instead, I enforced SSH version 2 for all management connections. I also implemented role-based access control. We have admin account with privilege level 15 for full control and users Aidos account with privilege level 5 for only monitoring and user Nietkali with privilege level 1. This addressed to the strict principle of least privilege. Now let's discuss the core of our defense, the zone-based firewall policy, ZPF. Unlike traditional access control list, ACLs, which are stateless, ZPF allow us to inspect the state of connections. I have configured class map to identify valid traffic TCP, UDP, ICMP. Then I apply distinct policies. For one to internet, I use the inspect action. This dynamically allows to return traffic back in. For internet to LAN, the implicit action is dropped. This ensures that no external actor can initiate to connection to our internal PCs. And for DMZ, I created strict policy allowing only HTTP traffic to reach the web server while blocking everything else. Finally, as the last line of perimeter defense, I deployed the Aidos intrusion prevent system, IPS. I created IPS rule and applied it to the gigabit Ethernet 2 interface, the one facing the router O. This ensures that malicious signatures are detected before they even enter our routing process. I also configured the router to log these security events, which my colleague will demonstrate shortly. Now that the secure infrastructure is built, I hand it over to my partner Aidos, who configured the AAA services and will perform the live penetration testing in our topology.
Thank you. As a AA specialist, I focused on centralized administration. We moved away from local database management and implement TACAS Plus protocol. Here on the server you can see the configuration of the router. The router requires this server for authentication. If the server goes down, I configured a local fallback method to prevent administrative lockout. And also for the test, I can say is in next because security is useless without visibility. I configured syslog monitoring every critical event, whether if a configuration change or a security alert is sent to this central server. This allows us to analyze incident in real time. Now let's the test system against the requirements. First, I can say test a latent access. I'm on the PC, admin PC inside the LAN. I will ping the router O and it will be success. The ZPF inspected the traffic and allows the reply. Also, in the next second test is we'll switch to the attacker. I laptop outside the network. I will attempt a ping flood attack against the internal network. As we can see, the request timeout. The firewall is doing its job, dropping unauthorized traffic. But did we detect it? Let's check the router. Here is the proof. The system logged the specific attack packets. We have successful detection and mitigation.
And to summarize all of our project, we have successfully implemented secure network using ZPF, IPS, and TACAX Plus, AAA authentication,
and all requirements from module 1 through 12 have been tested. Thank you for your attention.
Thank you for your attention. Goodbye.